I will be talking about Scapy and the ISO SAE 21434. I'm here today under the name of TU Graz, but actually I work for KTM. So we build orange motorcycles, and we have a weird relationship with our logo when it comes to public speaking. So that's why I'm here under TU Graz. Yeah, I'm doing my PhD in automotive cybersecurity, and yeah, I will represent the OEM side today a little bit. So when giving such talks, you never know your audience. So I guess when we're talking about Scapy, there will be a lot of computer experts. So just to show you a little bit the difference between maybe our lives. So what you guys use for cleaning your devices, maybe such a nice air duster, and what I use to clean my devices might be a pressure washer. So you might see the electronics in different computer systems are quite different. So the ECUs in our motorcycles, they have to withstand a lot of different things than a regular computer would use. That's why we are in a very constrained environment, and also we are always some years behind. We are a lot of years behind the computer industry, and we are also like 2 to 3 years behind the automotive industry with the four-wheelers. Unfortunately, the very boring topic, but it's giving me my job. These are different cybersecurity regulations that are coming up, especially in the European market. And for all the automotive industry, the green line at the bottom is the R155 regulation that says you need a cybersecurity management system if you want to sell a vehicle that has a license plate on it. Let me say it like this. But we also sell motocross motorcycles, for example, that are not homologized. So these do not fall under the 155, but they fall under the Cyber Resilience Act that some of you might know. So this is a regulation that the European Union came up with the Green Deal, and I think it was designed for routers and smartphones. And these people were saying all components that have a digital element, they have to be secure. But I don't think that they thought about that this will also hit like electric toothbrushes or also motocross bikes, for example. So as you see in 27 and also 29, there's the big showdown for us where we have to build secure components, secure bikes that we can still sell something on the European market. This picture I stole from the ISO standard. It shows a little bit the V model that we use to develop automotive components, automotive electronic components. And today I'm talking about verification, and we can see it on the right side of the V model that we as an OEM also have to verify that our suppliers really did what we told them to do. So here I showed it the same V with a little bit another wording. On the left side we see these regulations that I showed you, and out of that regulations it is my job to create these vehicle requirements, and from the vehicle requirements we create function requirements for all our components, and these requirements we pass on to our tier 1 suppliers. And they have to create component requirements from our function requirements, test them somehow, I don't care for now how they do it, and then they provide us back the component, the ECU, and we will do some verification. And this is exactly where you could use Scapy, and also where I use Scapy in my daily business. And after that, after the verification, there comes the validation. And for this, we at KTM, we use external pen test partners like Dissecto or Auxilium, who are doing a great job. And we do all of this stuff just to hopefully pass the audit or the assessment for the 155 or for the Cyber Resilience Act. So now let's talk a little bit about verification and different ways how you could do it. So first of all, how I started out is to do it the manual way. Yeah, we talked already about Windows and that it might be not so nice, but if you work in a corporate environment, you might have to use it. So I started using VirtualBox to run some Linux, because like Niels told us, everything is much better on Linux when it comes to automotive protocols. And yeah, I was playing around with SocketCan, Wireshark, and yeah, this is really error prone. I wasted a lot of time, and also my colleagues, from the automotive development, they use a lot of vector tools on Windows. Some people might like them. I personally, I don't. So yeah, this is how I started out. And then I found, or also Niels showed us, that you could use Scapy, especially the automotive section of Scapy. So on the left side, I show a little bit the different layers from the Scapy documentation, and in red, these are the protocols that I use the most. So pretty basic: CAN, ISOTP, and UDS. And what is really nice about Scapy is that these are really solid implementations, and I can use them really, really fast without doing a lot of errors like I did before. And the single most thing I use are the nice enumerators. For example, here we have the UDS service enumerator. I will give you later a quick example how it looks. So now I will show you the process, how we derive the requirements and how in the end we can verify them. So I just took out of the Cyber Resilience Act a very nice requirement that is very high level, and it says the product shall ensure protection from unauthorized access by appropriate control mechanisms. And yeah, so you can now create some different vehicle requirements from this. And one of them might be the vehicle shall only provide diagnostic access according to the OEM's diagnostic specification. So if KTM sends to some tier 1, yeah, we tell them to build a component for us, we give them also our diagnostic specification. And then the vehicle requirement is that there should be no other services, for example, available. So out of the vehicle requirement, I create again, it's always maybe factor 5, another set of function requirements. And like I told you, there should only be the OEM diagnostic services, and there should not be any undocumented UDS services. So now I take my big fat list of all these requirements and I give it to my tier 1, and yeah, they will just say, yeah, sure, I will do it. But the question is now, can I really trust these guys? And also, I want to trust them, and also I have to show, in the case of an audit, that they really followed up on my requirements. So now, how do I check if they really implemented it? And let's stick with our example about only using the UDS services that I specified. Yeah, the logical test case would be, now we are on the right side again of the V cycle, to just check all the available UDS services. And when I go now in the manual way, use SocketCan, etc., I will waste again a lot of time. And with the Scapy Automotive, these are, I skipped now the import statements. These are basically 4 lines of code. I use here the nice UDS service enumerator. I scan it for 10 seconds, and then I will get all my test cases. So here is an example output of this thing. I stole this from Niels' website, so thanks for that. Here you can see I got 128 negative responses, and I see all the different UDS services that are available on my ECU. Now I can take my KTM diagnostic specification and compare the list. Is everything there, or is there maybe something that was not specified? And with this, I can be really quick, and also it is really robust. So there is also another use case for Scapy that I personally use in my daily business, and this is to give support to our system engineering guys. Scapy is really nice, in my opinion, to hack up something quickly and to give some quick proof of concept. So for example, as a proof of concept, I want to show my guys that we could use secoc on different ECUs. So I would just spawn some Python processes that resemble the ECUs. I use Scapy for all the packet handling, and I can easily build a proof of concept in one day to show how we could do things like key distribution, show different communication protocols, and it is really nice and scalable. So this was already really cool, but now we will take it to the next level. Something that we started to use at KTM is the HydroVision project of dissecto, and this should really help us to automate the verification of our requirements even more. So I hope it's fine that I show some pictures of you guys. Yeah, this is the hydro probe. On the right side, we see my test bench. Yeah, it's still in the baby shoes. And there is some anonymous ECU that I connected. And yeah, the hydro probe offers me 2 CAN ports, 2 power supply units that I can use to change the voltage of the ECU, to reboot it really quickly. And it also gives me power monitoring tools. And we use the web page of the HydroVision to create different test plans. We want to test every requirement that we give out to our tier 1s and create some nice reports out of it. Because if we have an audit, the auditor, he or she will not be happy to look at my Python source code. They want some readable reports. Yes, and usually for all ECUs you have different, very similar requirements, so these test plans are really nice. I will always test the same stuff. What is really cool about the HydroVision is that you have the live test case execution. You can see the power trace of the ECU. You have some really nice logging that you can filter, and also you have the detailed reports per the test case. So yeah, we're just building up the system, and we hope that using it we may pass our security audits that we might have in 27, 29. Yeah, with that I think I will conclude pretty early and hope for some questions of you guys. Thank you very much.
Thank you for the interesting talk. Can you just give a little more details about especially the power monitoring and what you were doing over there?
Yeah, so if you take a look here at the picture, I think it's really hard to read, but the power monitoring, it allows me to really run my test case. For example, one test case might be the UDS service scanning that I showed you. And for the entire test case, I will measure, or the device will measure the voltage and the current of the ECU and give me here a nice graph where I can see what's going on. So this is really good. As we talked before, if I would use it as for a fuzzing test, I could see here exactly when the ECU will boot up again. And yeah, so that's really good. It might also be an idea, and we have discussed this already a little bit, that you could possibly use it for a side channel power analysis, for AES decryption, for example. But yeah, we did not try that out already yet.
So it was here used only as one of the vital parameters of the ECU to have a look at.
Yeah, it's always running anyways on any test case. So yeah, here in this specific test case, it doesn't provide me really crucial information, but it might in other test cases.
Okay, thank you.
Do you use it as well for the voltage glitch test?
So the question was if this HydroVision is also used for voltage glitch testing. We do not yet, so we are still, as I said in the beginning. Also, I don't know if the resolution of the power measurement is good enough. Maybe it's a question for the developers. But yeah, I think this would be a really interesting use case also.
Do you put ECU in current bikes or just in the future? And when will this be on the market?
So when you develop automotive ECUs, you always have some different stages, and for me it only makes sense to do the security testing in the very last stage, because there's A, B, C, and D sample in our case, and up to the C sample the tier ones, they are still fighting to have the basic functionality, and then only at the D sample they will do the advanced security stuff. So for now we are using it since I think half a year now. It's not used on any bikes on the market, because we have I think a development time when we start developing until you can buy it about 5 or 6 years. So that's why we have to start now to be ready in 27, 29 when it really becomes crucial.
All right. Thank you again for your talk.